In this video, let us look at matrix multiplication. That is, how you multiply two matrices. So matrix multiplication is not as straightforward as matrix addition and subtraction. So if you have a M by N matrix here, and if you have a P by Q matrix here, for matrix multiplication, both the matrices need not be of the same order. This is the first thing that you need to understand. For matrix addition and subtraction, both the orders of the matrix have to be exactly same. But for matrix multiplication, this order and this order need not be same. So can we multiply any two matrices? No. So what is the condition that two matrices are compatible to multiplication? So two matrices A of the order M by N and B of the order P by Q can be multiplied if number of columns in the first matrix A, the number of columns in the first matrix A is equal to number of rows in the second matrix B. So two matrices A and B can be multiplied in order AB. I'll say in the order AB if the number of columns in the first matrix is equal to the number of rows in the second matrix. That is the condition. That is, if the first matrix is of the order M by N, the second matrix is of the order P by Q, N has to be equal to P. So this number and this number have to be equal. That means if the first matrix is of the order M by N, the second matrix should be of the form N by some Q. Because P is equal to N, I can replace P with N. So if these two numbers are equal, then two matrices can be multiplied. And if these two numbers are equal, now these can be multiplied, and after multiplication, you get a matrix whose order is M by Q. M by Q, the first number by the last number. For example, if you have A 1 by 2 matrix, if it is multiplied by B 2 by 4 matrix, then you get AB of the order 1 by 4. First number by last number. And for these two to be able to be multiplied, this has to be equal to this. The number of columns in the first matrix should be equal to number of rows in the second matrix. So if the first matrix is of the order 2 by 3 and the second matrix is of the order 3 by 2, these two can be multiplied and the resultant AB will have an order of 2 by 2. So I hope you are understanding the compatibility of matrix multiplication. So let us take further examples into this compatibility concept. We'll see how to multiply after that. Let us consider the following questions. In this, you're given the order of A, the order of B, and the order of AB. And some numbers are given and some numbers are unknowns. So now you're asked to find the unknowns corresponding to the information given to you. In the first question, A is a 1 by 2 matrix, B is an X by 3 matrix, and AB is an M by N matrix. So from this information, can you get X, M and N? So first, A is a 1 by 2 matrix, B is X by 3. For these two to be able to be multiplied, compatible for multiplication, these two numbers have to be equal, right? Number of columns in the first matrix and number of rows in the second matrix have to be equal. So 2 has to be equal to x. So x is 2. So once x is 2, now once these two matrices are multiplied, what is the resulting order? First number by last number, 1 by 3. So m has to be equal to 1, n has to be equal to 3. So if you are given 3 numbers, you can find the other 3 numbers. So here, x by 3 into m by 2. So if these two are to be multiplication compatible, this number and this number have to be equal. So m has to be equal to 3 now in this question. So once m is 3, what is the resultant order? Resultant order is x by 2. So x by 2 is equal to 1 by n. So x has to be equal to 1, n has to be equal to 2. Next, if you have a 2 by 4 matrix into m by n matrix, you're getting x by 3 matrix. So 4 and m has to be equal, and once you multiply this, you get a 2 by n matrix. So if you compare, x has to be equal to 2, n has to be equal to 3. Next, m by n into 2 by 3 is 3 by x. So for multiplication compatibility, n has to be equal to 2, and the resultant matrix is an m by 3 matrix. On comparison, m is equal to 3, x is also equal to 3. So I hope you're understanding the basic conditions for multiplication compatibility and the order of the answer that you get, the order of the product that you get. So for matrices to be multiplication compatible, number of columns in the first matrix have to be equal to the number of rows in the second matrix, and the resultant product is of the order number of rows in the first matrix by number of columns in the second matrix.